So today I have the great pleasure of speaking with Brian McNamee, and Brian is Associate Professor in the UCD School of Computer Science. And today we will chat about training the next generation of machine learning leaders. Hi Brian, how are you today?
Hi Patricia, I'm doing great, and thanks very much for inviting me to do this conversation today.
Well, it's wonderful to have you, Brian. And first question for you today is, where are you located, Brian, and what's been keeping you going over the last few months of lockdown?
So I am in the attic in Stony Batter in Dublin 7, so working from home there. And I guess during lockdown, we've been doing all the things that everybody else is doing, like baking bread and going for walks. But one great thing has been, just at the beginning of last year, my parents were cleaning out their attic at home and gave me a giant box of all my Lego from 30 years ago or so. So myself and my daughter have been building Lego castles and pirate ships and things like that, which is great fun.
Sounds wonderful, Brian. So Brian, you are Associate Professor in the UCD School of Computer Science. Can you please tell our audience about your research and what makes you so passionate about what you do?
Yeah, so I work in computer science here, and my research is in machine learning, which I suppose some people would see as a branch of artificial intelligence. I think really I can describe it as sort of having two paths. So one area that I work on, which is the sort of fundamental research part, is developing what we call human in the loop machine learning algorithms, where we try to blend the best of what computers are good at with the best of what people are good at and bring those two things together in the machine learning algorithms that we build. And then the second part is basically applying machine learning to lots of different areas. So everything from agriculture to medicine. I think the two things that get me really excited about it is, one, I just really like disappearing into clever algorithms. So that feeling you get when you read a paper with a really neat solution to something, I really love that. And then the other thing I think that's a real privilege that we get to do is that the teaching side of it. So both working with, let's say, PhD students and in the teaching that we do in our different courses, and being able to, I suppose, go on a journey with people through sort of uncovering those themselves and then learning back from them when they discover new and exciting things themselves.
That's fantastic, Brian. And I think we'll have lots of questions about that. So don't forget to submit them to our audience. But it really leads me on perfectly to my next question. And that's about your title, Brian. So you are Centre Director of the SFI Centre for Research Training in Machine Learning. Maybe you can give our audience a kind of a 60-second overview of this.
Yeah, so the CRT in machine learning is a new type of centre that SFI started to establish about 2 years ago. The kind of two big things that we do in our centre, which is a collaboration between ourselves and UCD and Dublin City University and the Technological University of Dublin. The two big things that make it stand out, I guess, is that it's all about training PhD students. So our whole focus is on developing a training program that really helps PhD students be, I suppose, as successful as they can be, both in their research and in the careers that they're going to go on to. The two things that we do around that is we train cohorts. So we start essentially a class of PhD candidates. We started two so far. So one in 2019 of, I think it's 24 students, and then another one of a little over 30 students in 2020. And they're going to go through their whole PhD sort of adventure together as a group. That's great for them because it means they have a lot of support around them, but it also means that because we have a large group, we can put in place a program around their research. So those people will still do sort of amazing fundamental research in machine learning. But on top of that, we have I suppose, a layer within the training program that tries to broaden their horizons, keep them from not totally disappearing down into the niche that their thesis is going to be written about, so that when they come out the other side of that PhD, they can, I suppose, be as successful as they can be.
Okay, and again, I am sure that's going to spark a lot of questions. But one thing I want to bring you back to before we finish our chat is your passion and for algorithms. And you have co-authored a book, believe it or not, audience, published by MIT Press, which is entitled Fundamentals of Machine Learning for Predictive Data Analytics, Algorithms, Worked Examples and Case Studies, which is in second edition and also available in 5 different languages. So congratulations, Brian, this is amazing. Do you want to tell our audience about this?
Yeah, thanks very much. You can tell our use of Google data to figure out the title and how many buzzwords and keywords we could squeeze into it. So that came out of, I suppose, a collaboration. Before moving to UCD, I worked in DIT,
Okay.
and one of my colleagues there, John Kelleher, the two of us were teaching a lot of machine learning. And I think through doing this, we kind of came up with a particular view on how to organize it. And we also found that when we were recommending books to students, that a lot of the really good books that are out there, they didn't cover things in as much depth as we needed. In particular, like really clear step-by-step examples of how algorithms work. So we kind of through discussion said, well, we should write a better book, and we should write, let's call it a different book. So we set out to do that, and then later on we brought another collaborator, a friend of ours, Aoife Darcy, who runs a consultancy company called Chrysalis, and she brought in a view around, well, very practical things of how we apply machine learning. So the book became a blend of all those different things, and so far it's been really fun to put together, and it's been really fun to see how people use it. And we do get a lot of feedback that those sort of detailed step-by-step examples of things are really helpful to people. It's always fun. Every now and then you get a little email from somebody or a Google alert to say some other course is using the book and people are finding it useful, from both students and people teaching machine learning.
Wow. Congratulations, Brian. And so we're finished our particular section of the chat, and already there are so many questions coming in for you. So let's kick off and try and get through as many as possible. So where will your graduate students go once they graduate?
Yeah, so I think one thing that's interesting within the design of the centers is that there's I suppose a recognition within computer science PhDs that the majority of those are going to industry. Okay. When they finish their PhD. So I suppose probably 5-10 years ago, it would have been the other way around, that the majority are maybe staying in academia, whereas now we're seeing many more go out to industry. So that's kind of where we see, I guess there's a whole pile of destinations that I think our graduates are prepared for, but I think one in particular is that sort of leader within an R&D group in a company. So we're working with lots of companies like Mastercard, Accenture, and the kind of R&D centers they have. I think the other thing that we already see, actually, a couple of students from our first cohort have already started a company. And I think that's something we'd be really excited about, to see how students might start spin out companies of their own based on their research work.
Wow, Mastercard as well. Because actually, I don't know if it's of interest to the audience, but there was so there's an article in Silicon Republic this week about your interaction with Mastercard. Is that right?
Yeah, so one of the features of the training program in our CRT is that our students go on placement with companies. So they spend maybe 3 or 4 months at some point during their PhD out working with a company. I suppose, again, that idea of broadening horizons so they can see how machine learning is used. And Mastercard have been a really great partner for that. And the first student who's gone out on placement went out with Mastercard. So CeADAR, so he went, actually just the beginning of this year. So he's been doing really interesting things there. And together with Mastercard, we did a nice little video between myself and Steve Flinter, who's the head of AI in Mastercard, and CeADAR, talking about CeADAR's experience. And it's been great. One of the things that we've really tried to build into the center is that our graduates are aware of, I suppose, what it needs to go from, let's say, a great research paper to deploying that solution, and that's what CeADAR is getting a great experience of.
Yeah, and that's actually, there's a lot of questions coming in around that, this idea of, you know, that students who are going to progress onto industry need a depth but also a breadth of thinking. So some questions coming in around that, like, how will you ensure this for all your graduates? Because actually, Brian, how many graduates will come out of this particular CRT?
Yeah, so we'd hope to have about 120 PhD graduates. So we're currently set up to train 4 cohorts. We're just doing recruitment at the moment for our third. We have 59 students currently in our first 2 cohorts. And so we'd expect at least another 60 or so, which is brilliant. And it's a great privilege to be involved in that much. We are actually just planning our next summer school, and it's great to go along to those and see inside all the research work that's been happening. And it's things like that, things like summer schools, boot camps, the placement activity that happens, where we do try to, that idea of broadening out what people are talking about. So we're lucky actually to have lots of industry collaboration on the program. So we have speakers from industry come in, talk to our students. One that's been great, John Glover from Alien, has given a few talks to our different cohorts, and he does a great job at teasing out, the difference between a research paper that achieves, a 0.2% improvement on a benchmark, which is great from an academic point of view, to making a decision to spend 6 months building that into a new product, and how you think about that. And he never gets to go after his sessions because he's plagued by questions, which is brilliant.
Okay, and just to kind of so 120 students, they're getting a huge amount of training, but maybe just diversity. How important is the diversity in this, and generally how important is diversity in ML, in machine learning? Because that's a question that's just come in.
Yeah, so people might have been following the news around that. There's a lot of news, or a lot of stories in the news at the moment. So people might be familiar with Dr. Timnit Gebru, who is working in Google, who was involved in releasing a paper that ultimately led to, I think, being fired from Google because of that. One of the sort of discussions going on in the background is around that story in particular, is the lack of diversity in machine learning. Computer science, I suppose, suffers from this a little bit, but we see it a lot in machine learning now. And I guess one of the consequences of that is the lack of perspectives as people are developing machine learning solutions. There's a movie actually just out on Netflix, Coded Bias, which is really interesting, looking into that.
Oh, I think we've been lucky to watch that.
Yeah, it's really interesting, and does a great job of exploring those issues.
Okay, so Brian, sorry, there's so many questions coming in, so I'm just trying to keep a flow. But how do you instill ethical machine learning into your teaching? So I suppose the graduates, how do you give them kind of like a flavor of ethics and bias, like you were just speaking about?
Yeah, so there's a mixture. So one is actually the diversity of the cohorts themselves. So we're quite lucky that within our cohorts, we have a huge range of backgrounds, from educational backgrounds, so different areas that people are coming from, whether they're science or the humanities, different ages. I think the ages of our cohorts span from people just out of undergrad to people coming back to education after a time in industry or doing something else, to people from all over the world. I think we have, 23 different countries represented in our current group. So one thing that's great there is in the discussions that we have at things like our boot camp and our summer schools, we get a great variety of perspectives there. The other thing that having a cohort allows us to do is specifically have activities in, let's say, our boot camps or our summer schools, where we bring in experts around machine learning of the law, machine learning and ethics, to basically take our students through those discussions. And I think that's one thing that the cohort model is great for, because we have a group. It's worth somebody's while to come in and talk to us. And we've been very lucky to have some really great speakers. The other thing is some of the research itself is addressing exactly that. So we have a number of research projects specifically looking at questions around bias, transparency, trustworthiness within machine learning, which is, I think, only going to become a bigger question as time goes by.
I fully agree. So Brian, we have so many questions, and so I'm going to try and get through kind of quick fire questions now, and so that we can finish up on time. So some kind of more general ones about machine learning for you. Will machine learning always require human expertise? Very interesting.
Yeah, I think yes. There's a few perspectives on that. Some people would say no. I guess the short answer to that is yes. And I think where we see that idea of human in the loop machine learning, I think that's where there's massive potential. The example that people always come back to is chess in relation to this. So for a time, the best chess players in the world were computer chess players. So there's people familiar with Deep Blue, the famous chess computer, and subsequent ones that have been built. But the current sort of best chess player in the world is referred to as a centaur, where it's a mixture between a human player and a computer player. And I think that's where there's massive potential. I think we'll see exciting things happen.
Okay, so augmented intelligence as opposed to artificial.
Exactly.
Yeah. So here's one for you. So try your best to answer this. Will machine learning ever be able to detect and eradicate misinformation, disinformation, deep fakes, and fake news?
Yeah, I think that's one where the answer is no. And where that augmented intelligence solution is probably going to be the most interesting solution. So if we look at the challenges that companies like Facebook or any of the online platforms are facing, the volume of content is just so large that automated solutions kind of have to be part of the solution to that. but the problem is too nuanced and too tricky. You can see it yourself, and what do you mean by fake news? Is opinion that drifts far enough in a particular direction, is that fake or is it not? So I think that's such a nuanced problem that we'll always see the solution to that is going to be a blend of people and machine intelligence together.
Yeah. Okay, Brian, so here's one. Do you think automated vehicles will dominate transport in the next 10 or 20 years?
I have this argument with my brother. My brother loves cars and loves driving, and I'm the worst driver in Dublin, probably. So I think possibly yes. I think we're going to see a big move. If you look, like, the acceleration of that is really fast at the moment. I think what we'll see is sort of hybrid type approaches, where in cities where environments can be controlled and where it makes sense to be able to instrument environments, I think we might very quickly see a move towards more and more automated transport. But there's sort of going to be, I think, for a long time, a last sort of 20%, 30% that's going to remain very, very difficult to automate. So that country road where you meet a herd of cows out in the middle of nowhere, that's a very hard problem to solve. Whereas maybe driving around an instrumented city is actually probably quite feasible.
Okay, very specific question on your CRT. So it says, Brian mentioned diverse experience with industry. Machine learning also has a lot of diverse applications in a lot of diverse academic disciplines, for example, earth science. Are academics from different disciplines included in the training as well as your PhD students? So
yeah, I think I suppose is the short answer. So we're lucky across, let's say, UCD alone. I think we have 8 different schools involved as supervisors of the center. So where we're basically, the students maybe are looking at an application of machine learning to some particular area. So we have that. We have, for example, Kathleen Curran from the School of Medicine is a great example of that. And we have lots of others as well. We also bring in people from other schools to talk to the students, which is great to be able to do that. So that's a real interesting area for me, that some of the machine learning becomes a little standardized, and then the interesting question is, how do we apply this to new and different areas? And we see a lot of that, which is good fun.
Okay, so last question, because we're completely out of time.
Yeah.
Where can machine learning in the future, in your eyes, make the biggest impact, Brian? 30 seconds. Sorry, we're completely out of time, but maybe have a go.
If I were to pick one example, I think medical screening is a huge one. I think there's a huge opportunity to have sort of that augmented advisor looking over the shoulder of doctors who are maybe very focused on specific questions, which is what they're meant to be doing, but having that advisor looking out for a whole range of things. I think there's a huge opportunity there.
Wow, great. What a way to finish. So we are completely out of time. So sincere apologies to all of those of you whose questions I didn't get to. I just want to take this opportunity to say a huge thank you to Brian. Thank you so much, Brian.
No, thanks a million for the invitation. It was great fun.
Most fascinating discussion today, and thank you for everyone for joining in. So you can sign up for our series at zoomforthought.ie, where you can also check out our list of upcoming speakers. So thank you so much, everyone, and see you all next week on Zoom for Thought. So thanks so much, and thanks for all the questions. Take care. Bye.
Bye.
Bye. Thanks, Brian. Bye.